Good evening. My name is Tim Couch, and I'm going to be giving a presentation on what is gravitational time dilation. Basically, I'm going to cover what it is, the definition, a very brief history on how it came about, and its uses and what we know about it. So the definition of gravitational time dilation is the difference in time that has passed dependent on an observer's position from a point of mass, uh, because mass has gravity, which we'll cover here in a second. And that's relative to the observer, not for the observer experiencing the event. So a little bit about the history of gravitational time dilation. It was first discovered by Albert Einstein in 1907 as he was walking home from work one day. He just had a little bit of a thought experiment where he um, thought it up and went on to produce a whole formula and a whole theory behind it. So mass is an important factor in gravitational time dilation. The more mass an object has, the more influence it has on time, because more mass means more gravity an object has. Time runs slower to an outside observer, uh, the more mass an object has. So when speaking about time, the fabric of space and time are not separate. They both exist together, and this is called space-time. They exist as one uh, individual object, for lack of a better term. And you can see that here in the image. The fabric is the grid around the sun and the earth. Light is basically a way for us to monitor. So light moves at a constant speed, which you can see there. The speed of light cannot change, and the lapse in time does not change for the person or object experiencing the event. And that includes light, if light is the object. So light moving closer to a gravitational source is going to have a warped path, which you see in the image here. So C to D is that warped path, or space-time being curved. So it's going to take light longer to get from C to D than it would from light that's not near a gravitational source. Um, an example of this would be from the movie Interstellar. A planet is located dangerously close to a black hole, and because of this massive gravitational force, extreme gravity of the black hole has extreme effects on time dilation. So in the movie, 1 hour on this planet equals 7 years back on Earth. Um, so to figure out even further, what is time? Is there a correct time? If we have time dilation and time is sort of all over the place based on its proximity to different gravity sources, is there one time that we consider an absolute time? This is the one that never changes and everyone follows. Well, the answer to that is time is relative. So this depends on what forces the object that you're referring to is subject to, or its frame of reference. So there in the image you have the sun and its how it warps space-time, a neutron star, and a black hole. So no, there is no absolute. Um, if gravitational time dilation is only noticed by the outside observer, then how is time for the person observing it at the event? Well, like I said earlier, light is constant, meaning the speed of everything is constant. So proper time is the time that the person at the event is experiencing. The difference in time is very small, and it takes a lot of mass to change that. So everything that has mass has gravity, like we mentioned earlier. And gravitational time dilation occurs around anything that has gravity, or another way to say that is anything with mass is going to have time dilation. But like I said, the amount is extremely small that we can't really perceive it on a scale that means anything. It takes something with very large mass to cause dilation to occur at a level that we can track without any specialized scientific instruments. An example of how minimal it is imagine you move to Jupiter from Earth. For your entire life, you would be rewarded with only an extra few minutes on your life. Um, And a counter to this, uh, you might say, is well, what if we moved closer to a planet that had a very large gravitational source, like in the previous example, when I talked about the movie Interstellar? Well, could we extend our life? The answer is the speed of the universe is constant, like I've mentioned already. Time is relative. So an outside observer might see you living um, far longer to them, but to you, time passes all the same. It also, because I said space and time are one plane, they're warped together. So gravity warps time, and since it's warping space-time, it's warping space too. So what we're seeing is not, um, in actuality, exactly what it is reality. An issue that gravitational time dilation provides us with is our modern technology, such as a GPS satellite. Uh, um, Clocks on satellites tick at a different rate relative to us because they are further away from Earth, which is the gravitational source that's causing time dilation. Our solution to this is basically our understanding of time dilation. We know quite a bit about it, and we know enough to be able to calculate those changes between the satellite's position and us down on Earth. So we can pre-program algorithms to take into account that dilation, make minor continuous adjustments, and then the satellite passes that with the information and data back to us with those adjustments. So as far as intensity to it goes, time is slower the closer you get to the center of an object's mass. So, for example, someone who lives at a higher altitude versus someone who lives at sea level is going to experience time quicker than someone at sea level. Um, in summary, gravity influences time, and for the most part, it's very minuscule until you get on very, very large universal scales. Our understanding is very, very small at this point, but we've come quite a long way. And right now, we use that to improve the technology around us. Thank you.